All right, young scientists, welcome back to another screencast for Chemistry 2. I kind of think this one ought to be a little bit shorter. Today we're going to be talking about concentration of solutions. We're going to measure concentration with a new unit called molarity. Molarity is a really important unit. It tells us how much stuff is dissolved in how much liquid, usually water. Molarity's unit is going to be a capital M for molarity, and it's just equal to how many moles, remember we talked about moles before, in how many liters. How many moles of the stuff that's dissolved are in how many liters of solution. So if we look at an example here, a 1 molar, that's our vocab, 1 molar solution of sodium hydroxide has 1 mole of sodium hydroxide, NaOH, in 1 liter of water. So a 1 molar solution has 40 grams of NaOH in it. 40 grams is 1 mole of NaOH. A 2 molar solution has 80 grams in that same amount of solution. So the amount of liquid didn't change, but now there's twice as much NaOH dissolved in it. A 0.5 molar solution has half as much. It has 20 grams dissolved. So a 2 molar solution is the same concentration no matter how much of it you have. If I have a big liter jug of Kool-Aid and I pour it into 10 different glasses, each of those glasses has the same concentration as the initial jug. This is what we call an intensive property as opposed to an extensive property. Remember, we measure molarity as moles divided by liters. So if I give you a problem like, what is the molarity of a solution composed of 5.85 grams of Ki, potassium iodide, dissolved in enough water to make 0.125 liters, I need to get moles divided by liters. Right now I know grams, and I know liters, and you already know how to turn grams into moles. So we'll use the molar mass of Ki. We'll say 5.85 grams of Ki, where there's 166 grams in a mole. This number of grams is the same as 0.035 moles of Ki. Those mean the same thing. Then I just do my moles, 0.035, divided by my liters, 0.125, and I get my concentration, 0.282 molar Ki. Notice that molar, capital M, means the same thing as moles divided by liters. They're the same. We can do the same thing, but do it backwards as well to find the number of moles. Since molarity is moles divided by volume, if we just multiply volume over to the other side, moles are volume times molarity. So if I ask how many moles of H2SO4, sulfuric acid, are present in half a liter of 0.15 molar solution, I say 0.500 liters times 0.150 moles per liter is 0.0750 moles. Notice, moles per liter is exactly the same as molar. I can interchange those units. And if I do liters times moles divided by liters, the liters will cancel out and the only unit left is moles. Let's try another one. How many moles of HCl are present in 1.2 liters of a 0.2 molar solution? Fundamentally, this is the same problem again. Moles equals volume times molarity, concentration. So 1.2 liters times 0.20 moles per liter is 0.24 moles of HCl. Now the only thing you need to be careful of here is that your concentration, your molarity, and your volume are in the same units. See how these both use liters? If I had given you the volume in milliliters, you would have needed to convert first, because milliliters divided by liters doesn't cancel out. It needs to be liters in both places. Let's try something a little more complicated now, putting together some pieces that you've already learned. If I ask how many grams of NaCl, notice that I said grams this time, are needed to make 250 milliliters of a 3 molar solution. Well, we're going to need to know the molar mass of NaCl. Sodium has a mass of 23 grams per mole, and chlorine is 35.5 grams per mole. So NaCl, table salt, is 58.5 grams per mole. Now, like I said on the last slide, we can't use milliliters here. We need to get it into liters. But you already know how to do that. 250 milliliters, where 1,000 milliliters is 1 liter, and now my milliliters will cancel out. And I can apply that with my concentration. I know that it's 3 molar. That's 3 moles per liter. And I know that a mole is 58.5 grams. So milliliters cancel milliliters, liters cancel liters, moles of NaCl cancel moles of NaCl, and the only unit left is grams of NaCl, which is what I wanted in the first place. It's one big unit conversion to give me my final answer. I then multiply the top, 250 times 3 times 58.5, and divide the bottom, divided by 1,000, gives me 43.9. And let's look at significant figures here really quickly. This is 250 point. That has 3 significant figures. 3 molar actually only has 1 significant figure. If I wanted it to have 2, it would be 3.0, or 3 would be 3.00. So my 250 has 3 significant figures. My 1,000 has infinite significant figures. Remember that there are exactly 1,000 milliliters in a liter. But my 3 only has 1. My 58.5 also has 3. This 1 is the problem. My answer can't really be 43.9. I need to round it to 1 significant figure, so it really ought to be 40. Notice that I didn't put 40 point or 40.0. This is just 40. There was a brief overview on concentration and how to use molarity. Like I said, this one's a little bit shorter.